Now we are here to discuss about one of the most important part of electric vehicles, that is batteries. We know that there are different types of electric vehicles and different sizes of electric vehicles: electric cycle, electric auto, electric bike, electric scooty, or electric car, electric bus, etc. Okay. However, in nearly all the cases, the battery is a key component. Okay. So first we'll see what is a battery. Okay. What is an electric battery? A battery consists of two or more electric cells joined together. Those cells convert chemical energy to electrical energy. Okay. The cells consist of positive and negative electrodes joined by an electrolyte. You can see over here. Okay. This is a electrode and this is the electrolyte. The liquid is a electrolyte. So this chemical reaction between the electrodes and the electrolyte, which generates DC electricity, happens in every battery. Okay. In few cases we will be having a liquid electrolyte, in few cases we will be having a gel electrolyte, and in few cases we will be having a solid electrolyte, but the working of the battery is the same. Okay. Finally, it converts the chemical energy to electrical energy and generates DC electricity. So firstly, what is the role of electric batteries in electric vehicles? Mainly, you can see it's an electric car, and you can actually see there is a battery, blue color ones, which is placed on the under part of the vehicle. Okay, on the lowest part of the vehicle. I will be discussing why it is actually placed on the lowest part of the vehicle and all in further sections. But the first thing you need to understand, in the classic electric vehicle, the battery is the only energy store and the component with the highest cost, weight, and the volume. Okay. So that's the reason it is considered as one of the most important part of electric vehicles. And when we come into the different kinds of batteries, okay, there are two main types of batteries. Okay, one is rechargeable and one is non-rechargeable. We can also say it as a disposable batteries. Okay, what are rechargeable batteries and what are non-rechargeable batteries? The only difference is, previously we have, as I said you before, there is a chemical reaction happening over here, right? What exactly happens is electrons starts moving from zinc to copper. Okay, and the electron starts moving. So the movement of electrons actually creates current and voltage. Okay, the movement of electrons actually create current and voltage. So in rechargeable batteries, what exactly happens is you can reverse that chemical reaction. Okay, a rechargeable battery or a storage battery or a secondary cell battery or accumulator is a type of electric battery. Once it is charged and once it is discharged, you can ion charged by reversing that chemical reaction. But when coming to the non-rechargeable batteries, you cannot actually reverse that chemical reaction. That's the only problem. Okay, so most of the non-rechargeable batteries are for one-time use and non-disposable ones or disposable ones. Okay, sorry. Now coming to the examples of non-rechargeable batteries. Previously, I hope you aware of remote batteries, right? TV remote batteries. So it is a one-time use and a disposable batteries, and clock batteries on toy batteries, you can see. And when coming to the rechargeable batteries, I know, like I hope everyone recharge your cell phones every time, right? It's a cell phone battery. You can also see lithium ion polymer. Okay, so it's a rechargeable battery, and laptop batteries are rechargeable battery, and coming to the inverter batteries are also rechargeable batteries. And there are lots of types of batteries. Okay, I'm going to discuss in later sections. But before talking about the types of batteries, okay, it is important to understand how to judge a battery. Okay, I am not talking about the types. Okay, I am talking about the different parameters how to judge a battery. Okay, if you went to a shop to buy a mobile phone, okay, you are going to compare two mobile phones, right? One mobile phone is having 4 GB RAM, one mobile phone is having 8 GB RAM. You prefer 8 GB RAM because it's having a more specifications, right? So more it's a RAM and a value is a parameter where you can judge your phone. In the same way, what are the few parameters which helps to judge your battery? Okay, so basically there are 9 to 10 parameters. Okay, you need to understand. If you wanted to go to any battery manufacturing company, or if you wanted to visit any battery shop, these are the parameters everyone have to understand. Okay. So, before that, and let me give you an example. I know, I hope everyone are aware of this motor. Okay. We used to play in childhood. Yeah. So, this is a battery, and always remember, battery having two terminals, one is positive terminal, one is negative terminal. Okay. So, one is a so the two terminals are connected to this DC motor. Okay. We say it is having only two terminals, so it is said to be a DC motor. Okay. Okay, fine. A basic DC motor. Now, always remember, there are two words, one is voltage, another is current. Let us suppose I am actually giving more and more load on this motor. What actually happens, can you tell me what actually happens? What actually happens is, it start drawing more and more current from the battery. Okay, it start drawing more and more current from the battery. The voltage will be same, but it start drawing more and more current from the motor. And let us suppose this battery is 3.7 volts, and this battery is 3.7 volts, and this DC motor works on also 3.7 volts. Okay, what happens if I give 3.7 volts to a 3.7 volts, then it start rotating with its full speed. Okay, I gave a full voltage, so it start rotating with the full speed. Okay, so what if I start giving only 1.8 volts? Okay, so what happens? The speed get decreased. Okay, so just remember that basic two terminologies, voltage and current. I will be also explaining the difference between those in next slides. Okay, but these are the two you have to remember basically. So, okay, coming to the parameters, how you can actually judge a battery in a vehicle. Okay, these are the few parameters: battery voltage, battery capacity, energy stored, specific energy efficiency, self discharge states, battery temperature, heating and cooling needs, battery life and number of deep cycles. Okay, after you understand each and every parameter, okay, in next session I will be teaching types of batteries, right? I will be teaching types of batteries, right? So, you can judge different types of batteries with these parameters. Okay, with these parameters, so that you can understand, okay, this kind of battery is good at these conditions. Okay, this kind of battery is better at these temperatures. So, you will be understanding all those things in further videos, but initially let us go for the parameters. Okay, what is a battery voltage? Okay, as I said you before, what is a current? What is a definition of a current? Current is nothing but the flow of electrons per unit time. Okay, current is actually nothing but the flow of electrons per unit time. Where there is a flow of current, okay, there will be a voltage. Always remember that. Why? Because let me give an example. Basically, everyone having a basic doubt is what is the difference between voltage and the current, right? So, let me give it you a short. Consider this picture as an example. Okay, there is a pipe or a tube, and there is a piston, and there is a liquid inside it. For few seconds, consider this fluid as electrons. Okay, so now what is a current? Flow of electrons is a current, right? So, if the fluid is moving, it produces current. Okay, now that's the basic definition according to in a layman language. So, if this fluid start moving, then current starts producing, right? Yeah, if this fluid starts moving, then current starts producing, right? Yeah. So, in order to move these electrons, or in order to move this fluid, what should I need? See, in this example I am having a piston, but in real time I need voltage. So, in a layman language, if you ask me, voltage is a force which used to push the electrons, and which creates movement in the electrons, which in turns create current. Okay, which in turn generate current. So, battery voltage is first parameter you have to understand before going into the next parameters. Okay, so basically this voltage is directly proportional to R. Okay, everyone knows that this voltage is directly proportional to R. Voltage is directly proportional to R. No. Voltage is directly proportional to, I. I'm sorry for that. I. So, after removing that proportionality, what we getting, voltage is equals to some constant into I. V is equals to IR. Yeah. So, that is about the voltage. Okay. The first thing anyone ask, the first thing anyone asks when they go to any battery shop is how much voltage. Okay. You can see the example over here. Yeah, look over here. See, this is the battery, and what are the specifications having here? What are the two basic specifications having here? One is voltage, 12 volts. Okay. Second specification is capacity. What are the units to measure the current is amperes, but what is the units to measure the capacity is ampere hour. A for ampere, H for hour. Okay. So, 75 ampere hour is the capacity which is going to be acting as a second parameter for any battery. Okay. Capacity of a battery can be determined in such a way, if a load or a motor draws continuously 1 ampere. Okay, if a load or a motor draws 1 ampere continuously for 1 hour, okay, then how much ampere hour battery you need is 1 ampere hour battery. Okay, the capacity of the battery you need is 1 ampere battery. Let us suppose I wanted to turn my motor for continuously 2 hours. Okay, so now I want to select 2 ampere hour battery. Okay, 2 ampere hour battery for 2 hours. Okay. Now, let us suppose I am having much bigger motor. Now, that bigger motor draws not 1 ampere, it draws 2 amperes. Okay, and I wanted to turn it for 2 hours. So, what it actually makes sense, 4 ampere hour battery is required for me. Okay, I hope you understand. And it will be, I will be giving you much clear understanding in practical sessions. Okay, but this is a basic in order to understand the parameters. Okay, in order to get the knowledge on parameters. Now, coming to the energy storage. Okay, another important parameter, energy storage. Let us suppose you are having some X battery and Y battery. Okay, X battery is having some voltage and ampere hours. Okay, and Y battery also having some voltage and ampere hour. Okay, I am going to write it over here. I am having some X battery which is having some voltage V1 and capacity, ampere hours is nothing but capacity. Okay, and capacity V1, and I am having another battery Y with voltage 2 and capacity 2. Okay. Generally, you know what is a watt? A watt is a term used to resemble power. Okay, a watt is a unit for the power. Okay, power. So, what exactly happens is voltage into capacity. What exactly happens is voltage into capacity. What is capacity means? Capacity means ampere hour. Okay, ampere hour means amperes into time. Okay, now what is power in turn? Voltage into current is said to be power. Okay, so finally what it actually happens, power is nothing but watt, time is calculated in hours, so finally it is watt hours. You are going to measure the watt hours. Okay, let us suppose my X battery is having 2 volts and with a capacity of 10 ampere hour. Okay, and my Y battery is having 4 volts and capacity of 10 ampere hour. Okay, if you ask me which one is having more energy storage, okay, it is this one. Okay, my Y battery 4 into 10. Okay, we got in 40. So, it is having the highest capacity. Okay, here it is 20 only. Got it what I am saying? So, this is how you can compare which is having the more energy storage between the two batteries. Okay. Next, specific energy. In order to understand this, in order to give you a clear picture, I use a picture over here. Okay, you can see this picture. Okay, specific energy is nothing but the amount of electrical energy stored for every kilogram. Understood what I said? Let me give you another example. It is a electric energy stored for every kilogram. In previous slide, what we calculated energy storage, right? Energy storage is calculated in watt hour. Okay. Yeah. So, it is nothing but energy storage per kilogram. Okay. Let me give a much more clear picture. Just go to a nearby battery shop. Okay, just go to a nearby battery shop and ask for a battery. Okay, ask for a battery of 12 volts and 60 ampere hour. Okay, just go for any electrical shop and ask for a battery of 12 volts and 60 ampere hour. Okay, and if you catch that and if you check the weight of it, it will be around 15 kgs. Okay, it will be around 15 kgs. So you asked for 12 volts battery and 60 ampere hour battery. Okay, 12 volts 60 ampere hour battery. Okay, now what is the energy of it? 12 into 60, which means 720 watt hour. Okay. Now, how you can actually calculate the specific energy? 720 watt hour per how many kgs it is? It will be around 15 kgs. Okay. So, what's the final value you got? 48 watt hour per kg. Okay. So, it is also one of the best specification, it is also one of the best parameter, in order to judge the batteries. Okay, and you know what, when you manufacture electric vehicles, as a designer, every designer will think of one of the most compact battery. Okay, compact battery means which gives you the best performance in the less weight. Okay, in the less weight or in the lesser space. Okay, so if you go to any shop and if you can able to calculate the specific energy, you will be in a position to understand, okay, what is the best specific energy. If you go to any shop and if you can calculate this specific energy, you will be in a position to understand what could be the lowest weight with the best efficiency. Okay, so as a designer, it is your responsibility to focus on batteries which is having the lowest weight, right? So specific energy gives you the conversion for that. Yeah. So coming to the next parameter, energy density. Okay, just look at it. So it's a battery, it is a battery, and you are having a positive terminal and you are having a negative terminal. Okay, and energy density is nothing but the amount of electric energy stored per cubic meter. Okay, another parameter. See, another parameter I would like to show you is, let us suppose, yeah, this is an electric car, right? This is an electric car, and every designer also wanted to see the size of the battery. Okay, the volume of the battery, the length and breadth of the battery. So every designer want the minimum size of the battery to provide the more energy, right? So how to judge that? How you can actually judge the best battery using the size. Okay, so in order to judge that only, we are here with the energy density parameter. Energy density is nothing but the amount of electrical energy stored per cubic meter of battery volume. So whenever you also go to the battery shop, also see the size of it. Okay, see the length, breadth and height, so that you will identify the size of it. Okay, depending upon the size of the battery, you can easily find out the energy density. Okay, once you understand the energy density, you can able to judge, or you can able to select which kind of a battery I can use to my electric car within a less space consuming, with consuming a very less space. Okay. So that's how energy density works. And see, and I will be definitely showing the difference between all these parameters of all the different kind of batteries in later sections. Okay, I will be showing all these parameters: energy density, specific energy, energy storage, etc. in all the in all the different types of batteries. I am going to differentiate each and everything over there, and at that time you will definitely understand much more, and you will get much more clear picture. Okay. So now coming to the another specification, energy efficiency. Okay. Energy efficiency is considered as one of the basic efficiency for any battery. Okay. How you can actually calculate this energy efficiency? Tell me one thing, efficiency. What is efficiency? Which efficiency means the better performance. Okay, the best performance. Consider a 5-year-old battery. Consider a 5-year-old battery which is present nearby you. You know what happens if you consider a 5-hour battery and work on 5-hour battery? If you charge that battery for 1 hour, it will work only for 10 minutes. Okay, because it's older battery. It undergoes many environmental conditions. Okay, like temperature, heat, cooling, everything. So I hope you understand. So the energy efficiency, how you can actually calculate the energy efficiency is energy during discharge divided by total energy consumed by charging. Okay, as I said you, if you consider 5 to 10-year-old battery, okay, the energy consumed by the charging is going to be very high. Okay, the energy consumed will be very high. This will be very high, and the energy during discharging is going to be very low. So the efficiency is going to be decreased. So energy efficiency is also plays a key role when we judge a battery or when we select a battery. Okay. Yeah, you can also see these parameters when I differentiate between different types of batteries. Okay, and another different parameter is self discharging rates. Okay. Have you ever experienced this? Okay, have you ever experienced this kind of a phenomena? Just buy a battery, buy a lead acid battery, okay, from the shop and keep it outside for 1 month. Okay, buy a battery when it is having a full voltage and keep outside for 1 month without using. Don't use it. Okay, and check the voltage after 1 month. Do you think it will be it is going to be 12 volts again? No, right? So what happens inside it? What exactly happens? You haven't used the battery, but why the voltage or the power is the same as before? It actually self discharges. Okay, most of the batteries discharge when left unused, and this is known as self discharge. This is important as it means some batteries cannot be left for long periods without recharging. The reasons for this self discharge will be explained in the later sections. The rate varies with the battery type and the factors like high temperatures and low temperatures, etc. Okay, I am going to give you crazy facts about it also. Let's have a look. Battery gradually loses its charging during periods of unuse. Yes, when you keep your battery after buying for 30 days in outside your home, it will definitely discharge even though you haven't used it. Okay, so in the same way, if you look at it, there are some crazy values. Okay, just have a look. Discharge rate means the discharging capacity. Okay, the discharge capacity doubles for every increase in 18 degree Fahrenheit temperature. Okay, understood what is it? So the discharge rate is going to be very faster it is approximately doubles for every 18 degree Fahrenheit. Okay, now coming to the few cells. Okay, flooded cells kind of a thing. As I said you, As I said you in first slide, there are types of batteries. Okay, electrode and electrolyte are the two components which are present in every battery. When I am talking about electrolyte, as I said you before, there are liquid electrolytes, gel electrolytes, as well as solid electrolytes, right? See, flood cell batteries is nothing but if the electrolyte is a liquid. Okay, in most of the lead acid batteries use acid inside it, it's a liquid. Okay, so that kind of a batteries are said to be flooded cell batteries. Okay, flooded cell batteries. 25% of its charge, okay, will be losing for every 30 days, and for every 30 days if the temperature is at 77 degrees Fahrenheit. 25% of the charge loses every 15 days if the temperature is around the battery is 95 degrees Fahrenheit. 25% of the charge is going to lose for every 7 days if the temperature is 113 degrees Fahrenheit. Okay, so batteries undergo this self discharging every time, even though you're not using it. Okay, so this is one of the major problem, and I'm also going to show you the different self discharge rates for different batteries. Okay, discharge rate for self discharge rate for lead acid, lithium ion, lithium polymer, nickel, cadmium, zinc, everything. I'm going to show every batteries in coming sections. Okay, and one of the important parameter everyone need to consider while manufacturing an electric vehicle is battery temperature, heating and cooling. Okay, although most batteries run at ambient temperatures, some run at higher temperatures and need heating to start with and then cooling when in use. Okay, have you ever tried to give a self start for your bike in cooler temperatures? Okay, that is, suppose when you're in Delhi at cooler temperatures like 5 degrees or 10 degrees, have you ever tried to give a what we say self? Okay, so if you see that at initially the bike will not start for at least 3 to 4 rounds. Okay, why? What's the major reason why for that bike to not to start? Okay, the major reason is temperature. Okay, so he's saying that in few bikes, okay, in few bikes some run at higher temperatures, means some run means you need heating for those kind in some that kind of environmental conditions. Okay, in some conditions, in others battery performance drops. Okay, at lower temperatures. Exactly, the battery stops working if you are at 0 degrees or if you are at 5 degrees centigrade, and it will automatically affects your efficiency of the battery, which is undesirable, but this problem could be overcome by heating the battery, right? So as you know, when you talk about the electric vehicles, the first company which comes in your mind is Tesla, right? So Tesla continuously having a proper system which heats and cools according to the requirement. Okay, heats and cools the battery according to the requirement. I'm going to discuss about that phenomena and that kind of mechanisms later, but just look at the parameters. Battery temperature, heating, cooling, and is one of the major condition you need to consider while you're manufacturing electric vehicles. When choosing a battery, the designer need to be aware of battery temperature. It is as a electric vehicle designer, it is important to give a proper what we say sealing for that battery, so that outside temperatures will not affect that batteries. Okay, so it is a basic need for any electric vehicles and has to take this consideration during vehicle design process itself. Okay, so this is one of the parameter, and another parameter is battery life cycle and number of deep cycles. Okay, yeah, battery life cycle and deep cycles. Battery life cycles and number of deep cycles. Tell me one thing, if you have a Android mobile phone, let us suppose you have an Android mobile phone and you continuously you continuously do charging and discharging for 5 times per day. Okay, you due to some work You continuously charge and discharge, like you continuously charge and remove your charge continuously for 5 times per day, which means 30 days per month means 150 times per month. Okay. Do you think your battery gives you a more life? No. The major reason is whenever you charge and discharge, the life cycles are going to decrease. Okay. The exact number depends on the battery type, and the exact number of life cycles actually depends on the battery type. This very important figure in battery specification, as it reflects in the lifetime of the battery, which in turn reflects in the electric vehicle running costs. More specific information about this and all battery parameter mentioned and explained in later sections, but always remember the discharge and the charging rates decides the life cycles of the battery, and not only discharge and charging rates but also the temperature and the environment plays a key role in the life cycles of the battery. Okay. And next, coming to the basic knowledge on batteries, by this we completed the parameters of the battery. Okay. And let me give you some basic knowledge on battery, how batteries actually work. Okay. First question, let us suppose I am having a requirement of a 12 volts battery. Okay. And I went to a battery shop and I asked for a 12 volts battery, and he said they are having only 6 volts battery. Okay. Then what should I do? So the concept I have to use is a series connection. Okay. So what actually series connection do? If I am having a 6 volts battery, okay, 6 volts battery and another 6 volts battery, and every battery is having a negative terminal and the positive terminal, negative terminal and the positive terminal. Okay. What I'll do is I'll buy a 2 6 volts batteries and I'll connect this negative to the positive. Okay. One negative terminal of the one battery is connected to the positive terminal of another battery, which actually gives a voltage of 12. The potential difference between these two terminals is going to be 12 volts. So this is how series connection in batteries works. Okay. Now in the same way I'll talk, as I discussed before, capacity ampere hour. Now this time I am having a requirement of 6 volts and 20 ampere hour, but when I went to the shop, he said they are having only 6 volts 10 ampere hour. So what should I do? So what I do is I do a parallel connection. Parallel connection is nothing but the negative terminal of the one battery is connected to the negative terminal of another battery. Okay. And the positive terminal of one battery is connected to the positive terminal of another battery. Okay. Now I start getting the I start getting the wires from here, and if you calculate the potential difference, the potential difference is going to be 6 itself. When you connect it in series, the capacity will not be changed. The voltage, when you connect it in series, the capacity will not be changed. Okay. The voltage is going to be changed, but when you connect it in parallel, the capacity is going to change, but the voltage will be remain same. So 6 volts, it will be giving me 20 ampere hour. Okay. So this is how concept use a parallel connection. Okay. So let me having another question. Okay. Now this time I need 12 volts and 20 ampere hour battery. Okay. So I went to a battery shop, and again he said he is having only 6 volts and 10 ampere hour. So what I have to do? So I have to purchase this time 4 batteries. Okay. After purchasing 4 batteries, what I will do is, for first 2 batteries, okay, I will make a series connection. Okay. I did a series connection. Okay. Now what is the voltage difference between these two terminals? It is going to be 12 volts and 10 ampere hour. Okay. And at the same time, what is going I am going to do the series connection here, and what is the voltage difference between these two terminals? It is going to be 12 volts and 10 ampere hours. Okay. Now I am going to make a parallel connections now. Okay. Parallel connections of this red and black and black. Okay. So I connected this red and red. Okay. And I connected this black and black, you can see over here, and I connected this black and black. Okay. After this, if I start getting the connections from the black and red, if I start seeing the voltage requirements, you can see 12 volts 20 ampere hour, okay, 12 volts 20 ampere hour is achieved over here. So in the same way, okay, in the same way, whatever voltage and the capacity you need, okay, whatever your voltage and capacity you require, you can actually make that using the series and parallel connections. Okay, why I am actually explaining this series and parallel connections in this video, when you take the examples of a lithium polymer or lithium ion batteries, okay, lithium ion batteries are nothing but the cells, basic cells, okay. That basic cells will be having a voltage of 3.7 to 4 volts, okay. But in electric vehicles, okay, when you use a lithium ion battery or a lithium polymer battery, you need to connect those batteries in these series of parallel connections in order to achieve the larger voltages and larger ampere hour or larger capacities, okay. That's it. This basic knowledge and basic parameters of the battery where you can where you will be positioned to judge what kind of a batteries you can select and what kind of a connections you can make. Okay. In next session, I will be teaching what are the different types of batteries and what are the how battery management system works.